Hello friends, in this video today we are going to find the general solution of the wave on a string which is stressed fixed at two ends of the string are fixed and it is struck by a hammer. Okay, it is struck by a hammer. Okay, so now you see we know the differential equation of stressed string. Differential equation of stressed string is given by this equation: second order partial derivative of y with respect to time t is equal to c square second order derivative of y with respect to x, right? So here is the equation number 1, and the general solution of this equation of equation number 1 is of this form, that y of x comma t is equal to summation s is equal to, sorry, here it's supposed to be 1 to infinity sine s by x by L. This position is x equal to 0 and this is x is equal to L, and length of the string is L, that means by into as cos s by ct by L plus bs sine s by ct by L. So this is suppose equation number 2. Now here you see that, so where s is equal to 1 2 3 dot 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 so on, right? So there are two conditions. Okay, now condition 1, here you see when t is equal to 0, at t is equal to 0, the displacement, okay, so the displacement y of x comma 0 is equal to 0 for all values of x. That means here we have considered that when this string was struck by this hammer, the time of impact, the time interval, okay, that this impact lasts is very small, that at that instant the impact, the disturbance produced didn't get enough time to spread all over the string. That's why we can say that displacement is 0 at that at the time of at the time when this string was struck. That means at t is equal to 0, right? But at the region where the this first impact of this hammer was experienced, okay, on the string, at very small region, there must be a velocity, okay, then it will be then the disturbance will spread all over the string as time passes, right? So here at t is equal to 0, the velocity, though displacement was taken as 0 because at that instant of impact, that the impact lasts for very small time, so that it didn't get enough time, the disturbance didn't get enough time to spread all over the length of the string during the impact. After impact, after a certain interval of time, it spread all over the string, but at the time of impact, the time interval of during the time of impact, it was very small, so it didn't get enough time to spread all over the string. But in the region where this impact was made, at that region, very small region, there must be a velocity. That velocity, that will be represented by y dot means dy by dt, right? That's represent velocity. X comma 0, that will be also 0, for x, except the small region of striking, that is the region is x is equal to a and x is equal to a plus dA. That is very small region. So this point is, suppose x is equal to a, and this point is x is equal to a plus dA. dA is very small. Okay, so hope you have understood this. Now you see, if we apply the first condition, if we apply this first condition, t is equal to 0 at displacement is 0, this is first condition, and this is second condition number 2. This is second condition, right? This is second condition, right? So now let us apply the first condition. Condition 1, at t is equal to 0, y of x comma 0 is 0. Now you see, if you go back to the previous slide, from this equation number 2, if this displacement is equal to 0, then let me write this right hand side. If we replace this t is equal to 0, this t is equal to 0, then what we're going to have, let me copy this equation number 2 and let me go to a new slide. Okay, just wait. Here you see, now at t is equal to 0, this displacement is equal to 0, right? And if you put t is equal to 0 here, this also 0, then what you're going to have, then you're going to have summation from s is equal to 1 to infinity sine s pi x by L as, here we're going to get cos 0 plus bs, then here we're going to get sine 0 is equal to 0. So this is replaced by this from this equation number after putting t is equal to 0, right? We know that sine 0 is 0, so that's why what we gonna have, this part gonna be equal to 0. So we have summation s is equal to 1 to infinity sine s pi x by L, then a cos 0 is 1, as cos 0 is 1 is equal to 0. So from here, let me clean this equation number 2. Which is already written in the previous slide. So this equation implies that as is equal to 0. This equation implies as is equal to 0. Now let's put this value of as in this equation number 2. Okay, so using this value in equation number 2, what we're going to have, so here you see this as becomes 0, so this term will be 0, so that's why equation number 2 becomes this y of x comma t becomes summation of this into this, right? Because these terms gonna be equal to 0, right? So hope you have understood this. So that's why what we have got after putting the value of as equal to 0 here. So let me write this one. Sorry, y of x comma t. So from equation 2, what we have got, y of x comma t is equal to this, and as this part is this part is 0 now, so that's why we're gonna have this part within bracket. So here let me copy this. So we have got this, right? So hope you have understood this. So now you see, let me take this as equation number 3. Let me take this one as equation number 3. Now let me take the velocity. Now y dot of x comma t. So if you differentiate this, so here you see this is function of t, right? If you differentiate with respect to time, then what you can have, summation s is equal to 1 to infinity. Then you see we're gonna get this, that sine s by x by l, this is not function of t, so we're gonna take this one as constant. Then bs, and if you differentiate this, then you're gonna have cos sine, s pi ct by l. Again, this part here you see, from this part will be so this is t, okay? So this part will be taken as constant, so that's why we're gonna get bs into s pi ct, sorry, not t, by l here. Then here we're gonna get this, right? Hope you have understood this. Now at t is equal to 0, y dot x comma 0. So now if you put t is equal to 0 here, then cos 0 will be 1. So that's why this expression can be written as summation s is equal to 1 to infinity. So let me write this one first, s pi c by l, then bs, this part become 1, right? Cos 0 is 1 on putting t is equal to 0. Then sine s pi x by l, this part is written here, okay? That's what we have got. Okay, now let me copy this last step and let me take a new slide. Okay, so here is the new slide, and this is the last step we have got. Now let us multiply both sides. Let me copy this one again. Sorry. Okay, so here you see what we're gonna do. We're gonna multiply. Just give me a second. We're gonna multiply sine pi, sorry, not pi, n pi, sine n pi x by l on this side as well as on the other side. Okay, sine n pi x by l. Okay, now let us integrate with respect to x on both sides. Now integrating both sides, let me copy this step. Sorry, just give me a second. Okay, now here you see. Okay, just give me a second. So let us integrate it with respect to x from 0 to l. So from 0 to l. So again here we're going to integrate this from 0 to l. Here it is dx. Okay, now you see result of this part, this integral here on the right hand side, this integral. So it's going to be either 0 for s is not equal to n and L by 2 for S is equal to N. Here this S and N are equal. Actually here N represents 1 2 3 dot 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 so on, and similarly S also represents 1 2 3, right? So that's why we're gonna take this result here. So this is a standard integral. Okay, so now you see here this part will be replaced by L by 2. Okay, so therefore what we can write, let me copy this. So here is the last step, and we can replace this by L by 2. That's what we have got. So here L cancels, right? L cancels. So that's why the result is going to be equal to here you see. So after integration we don't need this summation. Okay, so from here what we're going to get, bs is equal to 2 by s by c integration 0 to L y dot x comma 0 sine n pi x by L dx. That is what we have got. Now you see by condition 2, according to that condition, that at t is equal to 0, the velocity y dot of x comma 0 is equal to 0 for all values of x except in the region x is equal to a and x is equal to a plus dA. So that's why what we can write, bs is equal to 2 s by c integration, instead of 0 to L, now we're gonna write a to a plus dA y dot x comma 0 then sine n pi x by L dx. That's what we're going to write. Okay, now you see if we substitute that okay, one more thing, let me go back to the previous slide. Here you see, as I have taken this result here, so this s is equal to n, so we can replace this n by s. Okay, so that's why we can write this here s. So that's why this is gonna be s. So here we're gonna write s. Okay, right. Now you see, okay, so here if you put x is equal to a, then dx is equal to dA, right? Dx is equal to dA. So and you see, since dA is very small, okay, this is very small, so that's why this part can be taken as constant, because in the region x to a plus dA, here you see these 2 points are very close, so that's why this value of sine function will vary not significantly. That means the value of sine at this point and at this point, the difference in their value is not significant. Okay, that's why what you can see that here you see, that's why this can be written as bs is equal to 2 pi 2 by s pi c integration 0 to L y dot x comma 0 dx. Okay, dx. And here if you take this one as constant, here you can write sine s pi x by L. That's how you can write. So instead of x, we're gonna put a now. Okay, substitute if we substitute x is equal to a, right? So here you see, if we use this value, first let me copy this and let me take a new slide. Okay. So here 2 s pi c sine s pi a by L. Let me take this part as a, capital A, where a is equal to this integral 0 to L y dot x comma 0 dx, right? And in that case you can write bs is equal to 2a by s pi c sine s pi a by L. That's what you're gonna have. Now you see, if we use this value, let me use this value. This is suppose equation number 4. Let me use it in equation number 3. So where is the equation number 3? Let me see this one. So we're gonna replace this bs by the value that we have obtained in equation number 4. So first let me copy this equation number 3. Let me copy this equation number 3. So this is the equation number 3. Now let me replace the bs. Okay, so then if we use this value here, then what we can write, then this equation number 3 becomes of this form. Let me show you. So y of x comma t, which is already written on 2a pi c integration, sorry, not integration, summation s is equal to 1 infinity. This s is written here 1 by s using the summation sine s pi a by L. This is a, okay, this is a sine pi, sorry, s pi x by L, then sine s pi c t by L. Okay, so using equation number 4 in 3, that's what we have got. Okay, right? And this is the general solution. This is the general solution of stock stream of, right? So hope you have understood.